We're going to continue section 4.3 by talking about setting up a system of equations with distance problems. If we read this one, it says two trains leave Tulsa, one traveling north and the other traveling south. After 4 hours, they are 376 miles apart. If one train is traveling 10 miles per hour faster than the other, what is the speed of each? So the question's asking what is the speed of each. That kind of helps us set up of what we're finding. So x is speed of train 1 and y is speed of train 2. And what I'm going to do is this one's a little bit quicker of a setup. Those boxes that we talked about yesterday in class. So I'm comparing train 1 with train 2. And if you think about what's really being talked about here, it's talking about time, it's talking about a distance, and it's talking about speed. And you may or may not know, but we use the formula distance equals rate times time. And that formula kind of helps us set up the chart. Rate times time equals distance. And we start filling in. So the time, it says after 4 hours. So that means both of them are traveling 4 hours. They're going to be 376 miles apart. So if we think about what's happening, this train's going that way, that train, so here to here, that's a total. And we're just going to use this right here and kind of say that as our total. The rate, we already established that with our variables. So x and y right there. So we have 4x and we have 4y. And like we talked about in class, this right here is one of our equations. Makes it super easy for the setup. 4x plus 4y equals 376. The other piece of information though we need from this is that one train is traveling 10 miles per hour faster than the other. So that equation right here kind of stems from this. And we can say that train doesn't tell us what train, so we'll just assume train 1 is 10 miles faster than the second. So I add 10 miles there. And that sets it up nicely to do a substitution problem. So 4 times y plus 10 plus 4y equals 376. And then we start solving this. 4y plus 10 plus 4y equals 376. 8y equals 366. Made a slight mistake here. That should be a 40. So then when we subtract it over there, it's going to be 36. So y equals 42. And if I take that 42 and plug it in, I get 42 plus 10. And so that x equals 52. And then it goes to interpret. So that's our last step. So train 1 is 52 miles per hour and train 2 is 42 miles per hour. We're going to take a look at number 5. This talks about an office supply store selling 2 objects, 7 writing tablets and 4 pens, and that cost would be $6.40. Whereas 2 tablets and 19 pens cost $5.40. Find the price of each. So again, price of each, that implies what we're trying to find. So X is our writing tablets. Y is the pens. And again, we're finding the price. I should put that in the price of pens. And we got to take the information and write some equations for it. So the first one says 7 writing tablets, 4 pens for $6.40. That right there is some information. We know that depending on what the price of the 7 tablets are and the price of the 4 pens, the total should equal $6.40. Well, to get the total price of what's happening in for the writing tablets, we need to do 7x, because that's how many are being sold and we don't know what price, plus the combination of pens and the price of those will give me 640. The next piece comes from 2 tablets and 19 pens. So I'm going to do 2x plus 19y equals 540. And what I want you to do is pause the video, and you can either do elimination or substitution and see what you come up with. What you hopefully got was that y equals 0.2, x equals 0.8, and what that means is that you're going to pay 80 cents for each writing tablet you have and 20 cents for each pen. For the last example that we have, it talks about measures of a triangle. What I'd like you to do again, I'd like you to pause the video, write out your variables, set up the equations, and then see what you come up with. This one's a little bit different than the other ones that we had. We actually set up 3 different variables because there are 3 different angles. So we have the largest, the smallest, the middle. You could obviously have put those in different orders. When it talks about the measure of the largest angle of a triangle is 90 more than the measure of the smallest, what I did there is that's the first equation, 90 more than the measure of the smallest. So I took 90, added to the smallest, which in my case was y. The second part is the measure of the remaining angle is 30 more than the measure of the smallest. So again, to find the middle, I added 30 to the smallest. Now this third one might be a little bit different, or hopefully you figure that out. A triangle is 180, so we have to add all 3 angles to get 180. Now, if we look at the equations yellow and green, they're both in terms of y, which actually makes this easy. So what we do then is I took x and I put in that 90 plus y. And I took that z and put in that 30 plus. And what happens is that whole equation then is by y. Real basic substitution, get everything in the same terms. And then I solved, getting the smallest angle, which is 20. And then I backtracked it to put into each of those equations. So I get 20, 50, and 110 for the measurements of the angles.